This video presents two demos for University Booth 2014 at DAG, Reconfigurable PV-powered full electric vehicle and SmartPatch, Storageless and Converterless Energy Harvesting Sensors. The works have been done in cooperation between Professor Nae-hyuk Chang's group in Seoul National University, Professor Hyung-kyu Lee from Daegu University, and Professor Dong-hwa Shin from Yeongnam University in Korea. Electric vehicles are considered as a strong alternative to engine vehicles, expecting low cost per mile, higher energy efficiency, and low carbon emission. However, they face some practical issues which prevents it from wider adoption in the market. One of the major problems is the short drive range. The energy density of the lithium-ion batteries is generally more than 10 times smaller than gasoline, which becomes a huge limiting factor in drive range. Also, actual energy efficiency considering electricity generation, transmission, and conversion is not very high. A major portion of the grid electricity is generated from coal and natural gas, which means the total energy efficiency is still subject to the inherent limit of thermodynamic cycle, just like engine vehicles. We plan to overcome these hurdles by maximizing energy efficiency, utilizing regenerative braking and PV panel installation on car surface. Our approach is inspired by computer-aided design of power systems of electric vehicles. We aim at applying CAD algorithms and design flow to EV design and runtime optimization. It is essential to obtain efficiency models of comprising components and acceleration-deceleration profiles to perform systematic optimization. As for applying CAD approach, we consider using hybrid electrical energy storage and reconfigurable PV power for extending drive range, enhancing mileage, and reducing battery degradation. We expect reconfiguration of PV array can cope with detrimental effects due to partial shading and PV cell faults during driving. We build an EV prototype for modeling and characterizing component energy efficiency and profiles. The powertrain of a compact car has been reused to form the powertrain of the target vehicle. The vehicle is front-wheel drive, where each front wheel is driven separately by two motors. The vehicle is 3 kilowatt or 4 horsepower and can reach up to 20 miles per hour. The mechanical parts and the inverter is capable of supporting much higher motor power once the battery system design completes. We anticipate the load demand and regeneration profile from the electric vehicle will be very helpful in performing computer-aided design of electric vehicles. Our second demo presents SmartPatch, a storageless and converterless energy harvesting sensor. Energy harvesting sensor systems offer longer life as it obtains energy from ambient environment without additional maintenance. The amount of power generation of energy harvesting devices fluctuates according to the environment and thus generally requires an energy storage for energy buffer. However, using energy storage requires power conversion circuitry to resolve mismatch between energy harvesting device, energy storage, and the load device. This so-called harvest store use architecture provides a reliable power supply, but it is costly and subject to efficiency loss in battery and converter. Moreover, the lifetime of the sensor is limited by the battery life. Our architecture removes the storage and power converter from design and directly connects energy harvesting device to the load by a MOSFET switch. PWM control of the switch controls the voltage supply to the load. This architecture benefits from increased efficiency and virtually infinite lifetime of the sensors. However, frequent switching of the load device means large DPM overhead, which means the approach is viable only with processors with very small DPM overhead. This is enabled by non-volatile processor technology developed by Tsinghua University. The DPM overhead is only a few microseconds. We propose a 2-counter based feedback control which offers more reliable duty ratio over a wide range of solar irradiance. This video shows how the duty ratio of the load changes according to the changing irradiance. please visit our university booth at DAC 2014. Thank you very much.